Hi ladies, this is Mrs. Blaufuss. This is the first part of section 4.4. The story problem at the end of your notes is on a separate video, so you can see Moodle for that link. But this is solving quadratic equations by factoring. Now, if you remember from last lesson 4.3, we solved a trinomial by factoring, but this a term here, this was always 1. So if you remember from, again, last lesson, we had x squared plus bx plus c, and we found two factors of c, and we called them m and n, and our goal was that m plus n equaled our b term. Okay, and then we could use those to factor. Now this lesson is going to be a little bit different because we do have an a term. So we have an a times x squared plus a bx plus a c. We're going to do the same thing here and look for factors of c. We're going to call those m and n. But now we also have to look for factors of our a term. And we're going to call those L and K. And now our goal is that L times N plus K times M equals our V term. So I'm going to show you a few strategies on how to make sure that you keep that organized, but find an organization strategy that works for you and stick with it, be consistent with it so that you can maintain that organization, because that's really key for this lesson and going forward. Okay, so on your note sheet, the first example, 4x squared minus 4x minus 3. We have to factor 4, and we have to factor -3. So our factors of 4, and sometimes this is going to be trial and error. So you have to practice with that. That's the only way to get better, is to just keep practicing. And the more you practice, the more efficient and faster you'll get, and more easily you'll be able to spot these patterns. Okay, so we've got our factors of 4, our L and K. We've got our factors of -3, our M and N, and we want it so that our L and N plus our K and M add up to -4. So 2 times -3 plus 2 times 1, that's -6 plus 2, that adds up to -4. That works. Okay, now some way that I've seen students do before, and you can use this strategy if it works for you, is list your A term, or list your first term, and then list your last term. Find the factors of 4, find the factors of 3, so 2x and 2x, and 1 and -3. And just to double check, 2x times 2x is 4x squared. That should be your A term. 1 times -3 should be your C term. And then here's your L and N times your K and M. So that's -6x plus 2x. And this should be your V term. So however way you want to organize that is fine. Just make sure that you're consistent so that you can keep up that same pattern. Okay, so no matter which way you use, now you have to put it into factor form. So 2x plus 1 times 2x minus 3. And then quick, if you double check your answer, 2x times 2x is 4x squared, 2x times negative 3 is negative 6, 1 times 2x is positive 2, 1 times negative 3 is negative 3. So you end up with 4x squared minus 4x minus 3. All right, let's try the second one. All right, let's look at this next problem. We've got 3x squared, and we've got positive 10. So let's come up with a couple factors of 3 and a couple factors of 10. So let's try 1 and 3, negative 5, negative 2. Now, the reason I chose two negative numbers for my 10 is because they have to add up to a negative number. So if they're going to add up to a negative number, I can't have two positive numbers added together because that will never equal a negative number. So I'm going to try it this way. And again, my goal is to get the product of these two numbers plus the product of those two numbers to add up to negative 17. So let's first make sure that I have my factors right. So 1x times 3x is 3x squared. And then negative 5 times negative 2 is 10. So far that's good. Now 1x times negative 2 is negative 2x. 3x times negative 5 is negative 15x. If I add those together, I get negative 17. So here's my first group, and here's my second group. So when I lay this out in factor form, I have x minus 5 times 3x minus 2. Now always double check. So I'm going to quick use FOIL to double check that 3x squared minus 2x minus 15x plus 10. And that's exactly what I wanted. Negative 2x minus 15x is negative 17x. So that is the same thing. All right, let's try another one. So I've got my two terms, my A term and my C term, and I'm going to factor those. And I want them to add up to negative 9. So again, I'm going to make sure that I have two negative numbers that make up, that are my factors of positive 2. All right, so 4, I'm going to use 4 and 1 for 4 instead of 2 and 2 because I'm just trying to think ahead and look for patterns, and I want those to add up to negative 9. Okay, so 4x times 1x is 4x squared. Oops. 4x squared. Negative 2 times negative 1 is 2. 4x times negative 1 is negative 4x. And negative 2 times positive x is negative 2x. When I add these together, those do not equal my b term. So either two things, either I'm using a wrong factor or I have them in the wrong order. So let's try again with the same factors, but switch up the order. So let's try, I can't remember what I had before. I think I had negative 2 and negative 1. So let's try negative 1 and negative 2. And let's see if it works this time with this order. Because sometimes that's all it is. It's just your order is off. So 4x times -2 is -8x. 1x times -1 is -x. So now that equals my middle term, which is -9x. So now I can go through, that will be one group, and this will be my next group. So when I write this out in factored form, I have 4x minus 1 times x minus 2. And again, I'm going to use FOIL just to double check my answer. So I get 4x squared minus 8x minus x plus 2, which is exactly what I want. -8 minus x is -9x. All right, and then we'll try one more. This one is nice because 7 and -3, they're both prime numbers, so there's not a whole lot of options. But we still want to set it up the same way. So 7x squared, we got 7x and x. And I want that to add up to -20, so I'm probably going to multiply my 7 and my 3 together. So I'm going to do -3 and 1. All right, now let's check to see how these all work out. So 7x times x is 7x squared. 1 times -3 is -3. 7x times -3 is -21x. And x times 1 is positive x. When we add these together, we get -20x, which, yes, this is our middle term. Then we're going to go ahead and write it in factored form. And those are going to be one group, and x and -3 are going to be another group. So when you go ahead and set this up into factored form, you have 7x plus 1 times x minus 3. Now, if you factor these out, use FOIL, just to double check your answer, that's 7x squared minus 21x plus x minus 3. And yes, that's what you want. That's exactly what you started with. -21x plus x is -20x. All right, so the next part of this is, yes, you can factor how we were just doing it, but sometimes it gets a little bit simpler if you see that you have a common monomial term. So if you can completely factor out a term from one monomial and you see that as a pattern, then go ahead and do that. Otherwise, you'll still be able to factor it. It'll just be maybe a little more complicated. So anytime you have a common monomial, then you can go ahead and factor it out. So for example here, we have 3x, 3, and 4 times 3, x squared. So there's a 3 in all of these. And so we can factor out that monomial, that 3. So that gives us 3 times 4x squared plus x plus 1. So 3 times 4, x squared, 3 times x, 3 times 1. Now, from there, we can see if we can factor any further, which in this case, we can't. So there's no factors of 4 and 1 that when you add up their products of the factors, that you get positive 1. So this is really as simple as we can go for this problem, but that won't always be the case. Sometimes we can see a factored pattern after we factor out a monomial. So for example, let's try the next one. So a common monomial here is 3 again. So we have 3x squared minus 9. And this x squared minus 9, we can factor out even further. So that's 3 times x minus 3 times x plus 3. And this is the difference of our perfect squares. 1 is a perfect square and 9 is a perfect square. So our difference of perfect squares, remember, is a squared minus b squared equals a minus b times a plus b. So that's how I did that one so quickly, just by looking at it. It's because we had that perfect squares rule. Okay, and then let's look at the last one. So for this last one, we have a common monomial term. We have 2, and 2 goes into 14, and 2 goes into negative 12. So we're going to factor out that 2. So we get 2 7x squared plus x minus 6. So now let's try and factor 7x squared plus x minus 6. Okay, so our factors of 7 are 7 and 1. Factors of 6 are, let's see, try negative 6 first. Negative 6 and 1. Alright, so let's first make sure that these work. Alright, so 7x times x is 7x squared. Negative 6 times 1 is negative 6. So there's my A, there's my C. 7x times 1 is 7x. Negative 6 times x is negative 6x. If we add these together, we just get x. Alright, there is my middle term, just my x. So now this is going to be my first group. And this is going to be my second group. So now writing this out in factored form. Don't forget about your 2. So it's 2 times 7x minus 6 times x plus x. Oops, x plus 1. Alright, so now again, if we want to double check our answer, which you should, remember multiplication is commutative, so it doesn't matter which one you do first. I work from left to right, usually. So 2 times 7x is 14x. 2 times negative 6 is negative 12. So now I've got this times x plus 1. Now I can use the FOIL method. So 14x times x is 14x squared. 14x times 1 is positive 14. Negative 12 times x is negative 12x. And negative 12 times 1 is negative 12. So I get 14x squared plus 2x minus 12. And if you look back at the original problem, that is exactly what you started with. 14x squared plus 2x minus 12. Okay, so that's how I know my factored form is correct. So this is my answer. Alright, now the next section is using the zero product property. Remember, the zero product property says that if one group, or if the whole thing is equal to 0, and you have factors, so x plus 4, for example, and x plus 2, then either this group has to equal 0, or this group has to equal 0. So you have to set both groups equal to 0 if the whole thing equals 0. So that's just a refresher of the zero product property again that we went through in lesson 4.3, so you can review your notes there. So we're going to use the zero product property now, but we're going to use it with a coefficient in front of our x squared term. So we're going to follow the same steps. First, we're going to set the equation equal to 0. Second, we're going to factor. Third, we're going to use the zero product property. And fourth, we're going to solve for the variable. Right, so let's look at this zero product property. Right now, our equation is set equal to 0. So we need to factor. We've got 2x squared, and we've got negative 21. So we want to find factors of 2, so I'll use 2 and 1, and factors of negative 21, so that when I multiply those together, they add up to negative x. So negative 21, I'll use, let's say, 3 and 7, and I want my bigger one to be negative, since my answer is negative. All right, so let's double check, does this work so far, what we have? With what we have? 2x times x is 2x squared. Negative 7 times 3 is negative 21. Now those both work. So now we can take 2x times 3, which is 6x, and negative 7 times x, which is negative 7x. If we add those together, we get negative x. That's our middle term, so that's what we want. So this is our first group, and this is our second group. So let's write it out in factor form. So we've got 2x minus 7 times x plus 3 equals 0. Now the zero product property says either 2x minus 7 has to equal 0 or x minus 3 has to equal 0. So let's set those equal to 0. So 2x minus 7 equals 0, or x plus 3 equals 0. So 2x minus 7 equals 0, and 2x equals 7, and x equals 7 halves. That's solving for x. If x plus 3 equals 0, then x equals negative 3. So here are our answers. As x is negative 3, or x is 7 halves. All right, let's try the next one. 4r squared minus 18r plus 24 equals 6r minus 12. First step is to set the equation equal to 0. So let's go back to our problem, and let's do that first. So we need to subtract 6r from both sides, and we need to add 12 to both sides. Then we can rewrite our equation. Whoops. So we get 4r squared minus 24r plus 36 equals 0. So our equation is set equal to 0. Our next step is to factor. So 4r squared, 36, those are the two terms we're going to focus on. And we want to add those together so that we get negative 24. Now, actually looking at this, I can factor out a common monomial term. That 4 might make it a little bit simpler. So let's factor out a 4 from each term. So I get 4 r squared minus 6 plus 9 equals 0. So I'm not actually going to need to do all that other stuff. Now remember our shortcut from last lesson is a plus b squared and a minus b squared. So we had a squared minus 2ab plus b squared. We're not actually going to use this one, but a minus b squared is a squared minus 2ab plus b squared. So I see that 1 and 9 are perfect squares. And negative 6 is negative 2 times 1 times 3. So that's how I can do this one quickly. You can do it the other way and you'll get the same answer, but just as a shortcut. So we've got 4 times r minus 3 squared. Now that's the same as 4 times r minus 3 times r minus 3. So now when we solve for r, we want to use the zero product property. The zero product property says this has to equal 0, or this has to equal 0, or this has to equal 0. So 4 does not equal 0. We cannot make that equal 0. So it's not going to be that one. R minus 3 and R minus 3 are the same thing. So R minus 3 has to equal 0. Therefore, R equals 3. So that's my solution for this last one. So I'm just going to scroll up so you can kind of follow along. We factored out the 4. And then we use the a squared minus 2ab plus b squared equals a minus b squared as our shortcut. And then we use the zero product property to get r equals 3. All right, so please jot down any notes if you want to see the video for the story problem. That one's a little long, so I'm not going to post in the same video. But please see that the link is on Moodle, and jot down any questions you have. Thank you.